All right, let's try something completely different. Let's try sockets. The idea on sockets is that we will have one GUI which will take the output of a second GUI and embed it. So the second GUI, for example, could have a movie playing in it. The movie won't play on the screen, but it will play through your GUI. We can do this with the MPV movie player, as a matter of fact. And there's some other code that's already been written this way. So the socket is not a networking socket in the sense of the internet, but it is a socket in terms of graphical user interfaces. All right, I am in, I've changed the code around a lot. Well, this is entirely new code because this is different than what we were doing, because most of this really is not going to be done in Glade. The code in here is going to some debris code, which is just backup code. I hope it's not important, but there's a client. That's where we're going to grab the output from. There's a parent that's going to do the grabbing. Get the usual compile script. We do have a parent Glade, which is in the background. We'll look at it. Parent-bin is the executable. Client-bin is the executable. We have two JPEGs, which are just a couple of meaningless, relatively small JPEG files because I want them small so they'll fit. It's not a large application. We also have a movie. It's the movie that's in the beginning of my YouTube page, so we can watch a movie in the parent GUI being played by the client GUI or the child GUI. All right. And what just crashed there? I don't know. Glade crashed for some odd reason. All right. Who knows? All right. First of all, let's look at the parent.glade. That's what I've got up here. It's very simple. It's very basic. It's things we've done before. I've got a window. It's relatively small. I've got a fixed in it. It's relatively small. I've got two buttons in it. One is called button. The other is called movie. They have all been set up so that their signals go to on movie clicked and on button clicked, the usual. This is the same as what we've done in the past. Should be completely normal. Let me just see if everything seems to be working. Yeah, it seems to be recording. I don't know what caused the Glade to disappear there. Maybe I clicked on it and I didn't realize it. All right, parent.c. Parent.c is going to look pretty familiar. There's going to be a couple of new things in it. The stuff at the beginning is pretty much the same. I have... no, somehow I ended up in the wrong one. I got two of them. That was the child. Parent.c. All right, still looks the same. All right, at the beginning, I've got a window. I've got fixed. I've got two buttons, button and movie, and I've got builder. We've seen those all before. This is just a very small application. It doesn't have a whole list of widgets at the front. The thing that's new is we've got a widget, which is a pointer, called sock. This is going to be the pointer to the socket. We are declaring here a couple of callback routines because they're not going to be handled by Glade. Maybe the destroy could be, I don't know. But anyway, there's going to be one callback called onPlugAdded. This will be called when the signal plug added, we'll see it in a moment, is invoked. But I have to declare these at the front now because they're not coming in through the builder. So they have to be declared as normally would be the case with a function you declared at the beginning. Another one is called onWindowDestroy. This is going to be called when the master window, the parent window, is destroyed, and it will destroy the child windows. Otherwise, you'll accumulate a lot of things running in the background. We have a global, these are all global, unsigned integer, socket ID. This is going to be a number that the system is going to give us, which is the number of the socket. We have a large string. It doesn't really need to be declared here, but it is. It's global. So that's it. We get into the main typical, arguments coming in from the outside world. We GTK init, same as before. We set up the builder. This time it's to .parent.glade. The window, same as before. We extract the information for the window pointer, for the fixed pointer, which is in the window, for the two buttons, all the same as before. We do the connection on the signals. That's same as before. I don't know if I put this into previous code, the unref of builder. It just deallocates it. It saves some space. If you left it off, if I left it off, it doesn't hurt anything. Just uses more memory. All right, here's a callback. First callback, a gsignal connect. That sets up the callback. It's a callback on the widget window, or on the window. If window gets the destroy signal, which it does when the window is destroyed, I want to call the function on window destroy. So if the destroy signal comes into the main window of the parent, we will call the subroutine on window destroy. Fine. Show all window, just show what you got, which would be, what you see in the background, basically, on the Glade thing. And I start GTK main. Everything's pretty much the same. It's actually much simpler than before. Let's look at button 1. There's 2 buttons here. One is going to just bring up a client that's going to show some static images. The other one's going to bring up MPV player. So we'll start with this one, the first one, the one that's the so-called button. First of all, I get the pointer to a socket. I tell the system I want a new socket, and it gives me the pointer to the socket. I then tell the system I want to set the size of the socket to be 200 by 200 pixels. You can make it bigger or small. That is the area that's going to fit in over here in the fixed area. You notice how I suspiciously moved everything over to the right, and there's an area over to the left. That's where the socket's going to be. I didn't want to move things around. It's going to be 200 by 200. You can make it bigger, you can make it smaller. We set up a callback. The callback is on the socket. So if the socket receives a plug added signal, we are going to call the routine on plug added, which was declared at the beginning of the program, so it won't say, hey, what's this? Undeclared or undefined function, because it knows what the function is. It was declared up at the top. Okay, so if I get a plug added, I'm going to go to the function on plug added. All it does is just say, hey, I got a plug. All right, I add the socket to the container, to fixed. Fixed is my container. I'm adding the socket to the container. Since I am not about to specify where, it'll by default go up the upper left-hand corner of the window back here. Okay. I then ask for a unique number. I ask for a number, which is going to be a large system number of some kind, and it'll come to me in hexadecimal. I'll be playing with it in hexadecimal. And GTK socket get ID, I pass down the pointer to the socket, and it returns me a unsigned integer, which I will use I'll send this to the client. The client will use it in order to connect back to me. Okay, I print it out, and I print it out in hexadecimal. All right. That's what that means there, and I'll have 0x in the front of it. It'll be hexadecimal, and it'll look hexadecimal in the string. Tell it to show all the windows again, just in case, even though but you're not going to see the socket yet because nothing's happened, but it will very soon. Next, I build a string in CMD, which was declared up at the top, and the string will be ./client-bin, that's an executable, and it will have as its argument in hexadecimal the socket ID. So it'll be a string saying ./client-bin some hexadecimal number. Notice the ampersand, which means I am going to detach and fork. I'm going to run this program separately. So when I call system, which creates a shell and runs the command, the shell detaches. The shell wanders off and runs by itself, and I will get control back. If you leave off that ampersand, you won't get control back, and this program will freeze, and you're not going to see anything. So you have to have that ampersand. Okay, it's gone. It's off and running. We'll worry about the other one later. So let's get out of there. Looks like a client .c. All right, stuff at the beginning is pretty much the same. Now here we have no Glade file, so everything's going to have to be declared and positioned and so forth, but there's not too much positioning to do here. So there's no Glade file for this. I've tried. It turns out you can't because the only thing you could do is a top-level window, and it kind of works, but not really. Anyway, I've got these are 2 callback functions for button 1 and button 2, and I'm declaring them up here. They're going to be callback functions. You'll see them down below. There's fixed, there's image, there's a bunch of buttons, and there's a plug. Those are pointers to widgets. The main thing up here looks about the same. I declare the socket ID here and I set it to 0. I then, the argument count should be 2. And the argument should be, the first argument is the name of the program. Second argument will be the socket ID, and I read it in. I do an scanf on argv1, argv0 is the name of the program, and I read in, denoting the fact that it's in hexadecimal, I read in the socket ID. This is the number passed to me by the calling program, or the invoking program. Otherwise, I fail miserably and go away, but you have to have that socket ID. I then do the usual GTK init. No difference there. Next is I create a plug. GTK plug new, and I pass it the socket ID. This gives me a plug that will fit the socket. This plug will go into that socket. It's all magic. It's done by the system magic. Okay, let's see. Button 1, I create a button, GTK button new with label. And the label in the button is going to say image 1. This is actually creating a button. This is what you did on Glade, but this is actually how you do it in GTK function calls. I create a button and it'll have the text in it, image 1. I create another button with the text in it, image 2. Create a third button with the text in it, quit 2. All right, callbacks. Got to do callbacks manually now. Notice there's no builder or anything. So for button 1, if clicked, I'm going to call on button 1 clicked. If button 2 is clicked, I'm going to call on button 2 clicked. If button 3 is clicked, I'm going to call GTK main quit. That's a function that already exists, so I don't have to declare it. That's why you didn't see a third callback declaration. And that'll end the program. All right, the next one. I am creating a fixed container. I'm not creating a window. I'm creating a fixed container. That's the thing usually underneath the window. This you don't create a window. You create a container, and fixed is the obvious one. You can use other containers as well, but that's as far. You have to use one of the containers. You can't create a window here. So I create a fixed, and I put into fixed button 1, button 2, and button 3. Okay. When I put them in, I'm telling them they're going to be at horizontal location 0. Vertical location 0, vertical location 30, location 60. So they're going to be buttons down the side of the screen, starting at the leftmost edge. The first one's going to be at the top, then at 30 pixels down, then at 60 pixels down. Okay, very simple. That's how you position the buttons into fixed. All right, the next thing here is, and we've done this before, is I get an image from a file. Now, there's one of my JPEGs, test1.jpg. All right, and I get a pointer, widget pointer to an image file, and so we've done this before, so it's pointing at the image test1. I then add the image to fixed. Notice I have to cast everything because everything was originally declared to be widgets. If I just passed fixed down, even though it is fixed, I'll get a complaint from the compiler saying, "Hey, that's not a fixed." So if GTK fixed casts it, and the compiler is happy, it is actually a fixed object. But you see all these casts all over the place. Okay, so I'm adding image to fixed, and I'm adding it at position 0 horizontal and 90 vertical. Okay, so it's going to be under, see, the buttons are going to be at 0, 30, and 60 going down, and then the image is going to be at 90. The image is going to be at 90. These are small images. I'm not resizing them. I'm keeping them so that they will fit into the ultimate thing I'm going to. Remember, we did a video on how to resize images. There's no dynamic resizing of images here. All right, so we have put the image into the fixed container. Now I add fixed to the plug. Fixed has been added to the plug. And I tell it to show all with the plug, which means, all right, well, it actually doesn't show on the screen. It'll show in the other guy's GUI. All right. And then I'm off to the races. There's my GTK main, and which, the main loop now starts running for this program. On window destroy, I guess I must have had a call. I hope I had a call back up there someplace. On window destroy, well, I don't see it. It's magic. It didn't complain. But there is, it runs GTK main quit. Oh, that's what I put up here, GT main quit. Yeah, I had a window destroy, but I never called it. That's superfluous code. It's GTK main quit, which I don't have to declare. If I had used window destroy, I would have had to declare it, but since I didn't use it, I didn't have to declare it. It's not been called by anybody. Button 1 clicked. Okay, if you click button 1, it'll print out button 1 clicked, and it'll appear in the same terminal window that initiates everything. I remove the image from the container. I get a new image. This one is test 1, so this is the same one we initially do. And I put it into the container at position 090, and I show the plug. The other button is very similar. It prints out button 2 clicked. It removes the image from the container. It gets the image associated with test2.jpg. It puts the image into the container and shows the container. It puts the image into fixed. Fixed is already in plug. It shows plug, and hopefully everything works. Okay, so what we've got is we've got a parent that's going to initiate a child called client-bin, and client's going to generate stuff, but that stuff is going to appear in the parent. So let's see if it works. I should compile it just to prove it. All right, there is the window. The window is kind of anemic because all I've got in the window at this point is just these 2 buttons. I didn't pre-size the window. I could have pre-sized. I can drag it and make it bigger. But anyway, I could have pre-sized it to something. But if I click this guy, this will invoke client. And when client gets invoked, it's going to put buttons. It's going to build a GUI, and it's going to put buttons, and it's going to put an image in its GUI. But its GUI is going to appear here. So here we go. There you go. And you see it's really part of this guy. There's not a separate GUI anywhere else on the screen. Take my word for it. There's nothing hiding behind anything here. And there's the image. And because the image and everything is bigger, it automatically resizes the parent window. That's normal. That's image 1. When you notice that button 1 clicked, here back in the background here, you can see the socket was created, and it's 0x44000DE. That's the which is actually a desktop ID that's used by GDK. There is a way of seeing that. You can see it with the program WMCTRL with the right parameter switch on it, and it'll show you those things. But anyway, well, let's see if I open in terminal. I think it's -L. Yeah, there you are, -L. There's parent-bin, and where's I don't see client in here. Don't know where client is. Client's not showing up here. It's not showing up because it's not visible on the screen. That's the reason why it's not showing up. Okay, get rid of that. That WMCTRL is one way of seeing those things. But it's not visible, so WMCTRL is not showing it, I assume. But if I click this, you see we say button 2 clicked, and we get a different image. If I click this one, and okay, I don't know why I said quit 2. There's only 1 quit, but and you could say I'm having a fun time going back and forth between the two. It's the proof of principle. What you're seeing on the screen is coming from a separate program. I'm capturing that program's GUI output, and I'm embedding it in this program. This program, the socket, it enlarges to fill the socket space being 200 by 200. But as you'll see when we get to the movie. Okay, quit 2. I don't know why I called it quit 2 and not just plain old quit. That clicks out or kills the client, and that kills the parent. All right, let's go back to the parent again. And on window destroy down here, by the way, which is kill all, client-bin, system program. That goes through and kills any instances of client-bin that may be lurking. You probably want to do that. And then it goes to a full-scale quit. So there's the on-plug added. I didn't mention it. That was the callback. I don't do anything with it. I just said, hey, plug was added. All right, the other button. This is the button for the movie. And then it's very similar. You get the pointer to the socket. You get the you size it to 200. You could do the callback to plug added. The same callback can be used by multiple entities. I put the sock into the container, into the fixed. I get the sock ID. I read out a message saying sock ID created, and it gives me the hex. I show all for the window. Okay, now I'm going to invoke the MPV movie player, which you need to have installed. It probably is, but it's a common player. The MPV movie player will play this game. If you pass it a socket ID, it will send the video to that GUI. And here is the commands. Again, we're creating a command. MPV is the --WID, window ID, I guess is what they mean, equals, there's the socket ID right there. And you see there's the socket ID over here that I'm actually writing in here. So --WID for MPV means you're passing to it the socket ID, and it will send its graphical output to that socket. Not only some programs do this. You can write your own program, as we've seen. I just did with client.c. But some programs actually do have this built in, and you'll have to look to find out. And the movie it's going to play is that guy there, pa.mp4. Notice the ampersand. Again, you got to have the ampersand, or this program will freeze up waiting for it to return, which of course it's not going to do. Not for a while, anyway. And you won't, in other words, you won't see anything as a result. And it shows me the command. Okay, I print out the command, and it runs the command. So what I should see here, when I click play movie, the area over here should fill with the movie, and the movie is the movie that's in the front of my YouTube. It'll probably have voiceover. The sound should be in it. I'm just looking over at the. Yeah, I think I can control the sound. Okay, here's going to play the movie and see what happens. Everyone, there's the movie. Colorful graphical user interface. Well, here it is. This is all in Glade, and I think you heard the sound there. I'm not sure. 12 parts so far in my YouTube page. Yeah, that's the sound of the movie. Of course, the movie is quite shrunken. This is a regular to fit into the area, but yeah, that's the movie. And you can see if I mouse over, you can actually see the controllers for MPV pop up. They're all miniaturized because they have to fit inside of 200 by 200. If I had made it 400 by 400, they would have been bigger. It sizes itself to the area available. Turn one on, but I only gave it a tiny area. This won't do it because the socket has been preset at 200. But in the background, this is not changing the size of the socket. It's just changing the size of the parent window from the slider. So this also, let me kill that. When you get a lot of messages from MPV and things like that, don't get too excited about them. It throws a lot of messages, but anyway, I'm not even going to worry about them. But so there you are. You can invoke a second program with its own GUI, capture that GUI, and embed it in your program, which is, for example, if you're writing an application and you want to embed a movie in it, that's how you do it. By the way, you could have turned off the on-screen display in MPV with some other parameters. MPV's got 1 million parameters. Again, I'll post the code to my website, which is all the code should be there, and you can play with it as desired.